Good morning to all. Welcome to my channel. In this video, we are going to discuss about types of parsers. Basically, there are 6 phases in the compiler. Among the 6 phases, the second phase of the compiler is syntax analyzer, in which we are going to construct a parse tree for the tokens. So, here there are various types of parsers are there. In this video, we are going to discuss about what are the different types of parsers, and we are going to concentration on more on the predictive parser. A parser can be classified into 2 types. One is top down parser and the second one is bottom up parser. The top down parser can be used to construct a parse tree from top to bottom, that is, we will start with the root node and reach to the leaves nodes, where bottom up parser can be used to construct a parse tree from bottom to top, that is, we will start to construct the parse tree from leaves nodes to roots nodes. Now, coming to the top down parser again classified into 2 groups. One is backtracking, the second one is predictive parser. Backtracking means where we are going to use, that is called as a recursive descent parser, means where we have to take the back to construct a parse tree. To overcome the particular drawback of backtracking, where we have to use that predictive parser. And coming to the bottom up parser, the bottom up parser again classified into 2 groups. One is shift reduced parser and the second one is left recursive parser, that is called as LR parsers. Okay. So, LR parsers again subdivided into 3 groups. One is SLR parser and LALR parser and LR parsers. LR means that is called as scan the input string from left to right, and R means where we have to use the rightmost derivation. And coming to the, that is called as what is a predictive parser. Predictive parser is a recursive descent parser with no backtracking or backup. It is a top down parser that does not require backtracking, means sometimes while constructing the parse tree, we may take the back to construct a parse tree. So, by using this parser, no need to go to the back, that means backtracking. So, that is why it is, so that is called as without having any recursive descent parser, means no backtracking. So, here to construct the predictive LL1 parser, where we must follow the 3 steps. The first one is compute first and follow functions for the given context free grammar, and the second one is construct parsing table by using the first and follow, and third step is parse the input string. That means we must follow the 3 steps here. The first one is compute first and follow, the second one is construct the parsing table, and third one is parse the input string. Now, coming to the first step of the predictive LL1 parser. Now, first and follow. So, first of all, try to understand what is the first function, later you go for follow function. Now, come to here, what is the first of alpha? First of alpha is a set of terminal symbols that are first symbol appearing at right hand side in derivation of alpha. That means, on the right hand side in the derivation of alpha, is there any terminal symbol? Those symbols can be considered as a first function. Means a simple definition of first function is first of alpha is a set of terminal symbols that are first symbol appearing at right hand side in derivation of alpha. While calculating the first function, we must know that there is a 2 rules we have to apply on the given context free grammar. The first one is, if there is a rule x derives epsilon, then first of x equals to epsilon, because of epsilon is a terminal symbol. And the second one is, if there is a rule x derives a and a derives b and b derives c, means on right hand side all are the non-terminals. If there is a first symbol as a non-terminal, then directly go to the particular production, and there is also a non-terminal on right hand side first place, then go to the particular next production, and come to here, there is a C production, C derives A or B or epsilon. That means where first of x equals to first of A, first of A equals to first of B, first of B equals to first of C. That means what are the symbols will get for the first of C, those symbols can be considered as a first of x, first of A, first of B equals to first of C. So, now let us see the simple example to understand clearly. So, what is the first function? Now, this is the given grammar, that is E derives A plus T or T derives T star F or F derives E or ID. Now, before calculating the first function and follow function, we must know that is there any left recursion or either left factoring. If there is any left recursion, then simply first of all we have to eliminate the left recursion, then calculate the first function. Now, what is the left recursion? The left hand side of the symbol appears on right hand side first place. If it is a non-terminal, those type of productions can generate infinite number of strings. That means where there is a left recursion, now we have to eliminate the left recursion. Means come to here, there is E, on the right hand side there is a E. That means the left hand side of the symbol appearing on right hand side first place, that production has left recursion. That means where we have to eliminate the left recursion from the given grammar. That means I already know that how to eliminate the left recursion. To eliminate the left recursion, we must understand that how we can eliminate the particular left recursion. The left recursion is in the form of A derives A alpha or beta. If there is any production is in the form of A derives A alpha or beta, then we have to eliminate the left recursion. How to eliminate the left recursion? We have to rewrite the left recursion rule, that is A derives beta A dash derives alpha A dash or epsilon. That means this is how we can eliminate the left recursion. Okay. So, that means where we have to rewrite the rule, okay, to eliminate the left recursion. What is the given grammar here? Now, there is a E derives E plus T or T. So, it is in the form of A derives A alpha or beta. So, now there is a left recursion, that is why we have to eliminate the left recursion. How we can eliminate the left recursion? Already you know that we have to rewrite the production, means to eliminate the left recursion, that is E derives T E dash derives plus T E dash or epsilon. This is how we can eliminate the left recursion. So, similarly we have to take that one more production has left recursion, that is called as T derives T star F or F. It is also in the form of A derives A alpha or beta. That means to eliminate the left recursion, where we have to rewrite the rule. That means T derives F T dash derives star F T dash or epsilon. This is how we can eliminate the left recursion. In the given context-free grammar, there is a left recursion. So, that is why we have to eliminate the left recursion by using this formula. So, now after eliminating the left recursion for this one, E derives T E dash, E dash derives plus T E dash or epsilon, T derives F T dash derives star F T dash or epsilon, and F derives E or ID. This is how we can eliminate the left recursion. Means before calculating the first function, we must eliminate the left recursion and left factoring if there is a left recursion or left factoring in the given context-free grammar. And now come to here. Now we are going to construct, that is called as what is the first function. Now, so already know that. So, what is the first function? The first function means, that is where we must know that what is the first function. That is called as, it is a set of terminal symbols that are appearing on right hand side first place. That means on the right hand side, if there is a terminal symbol, those symbols can be considered as a first of E. I understand. Now, what is a first function? So, what is the first function? How to calculate the first function? Means now here, now look at the particular e. First of e equals to first of t. So, because of it is a non-terminal. On right hand side, there is a non-terminal. Means now we have to apply the second rule of first function. First of e equals to first of t. Why it is a first of t? First of t means that is called as a t is a non-terminal. That's why we are going to take the first of t equals to first of e equals to first of t. Now come to the first of t. So what is the first of t? On right hand side, non-terminal f. That means first of t become a first of f. So now because of it is a non-terminal. Now come to the first of f. First of f has that is called as a terminal symbol. There is a two productions that is called as what is the first of f means. So first of f become that is called as open bracket and id. These two symbols can be considered as a first of f. If the open bracket and id can be considered as a first of f equals to first of t. First of t equals to first of f. Okay, so this is called as what is the first function. What is the first function? Okay, so that is first of e equals to first of t. First of t equals to first of f. First of f equals to open bracket and id. That means e t. Now come to the t production. Now t has a non-terminal symbol. Again come to the f production. F has two terminal symbols that is called as open bracket comma id. That's why we will take that first of e equals to first of t. First of t equals to first of f and open bracket and id. Okay, so this is called as what is the first function. Now first of e is over, t is over and f is over. Now come to the second one, e dash. First of e dash, what is the first symbol here? Plus and epsilon. So plus and epsilon both are the terminal symbol. That's why we will consider that first of e dash equals to plus comma epsilon. Similarly, come to the first of t dash. First of t dash equals to that is called as star and epsilon. Because of on the right hand side, first symbols are the terminal symbols. That's why we will consider that first of t dash equals to star comma epsilon. So this is how to calculate the first function. And next one is come to the follow function. So same, come to the what is the follow function. Follow function, follow of a is also a set of terminal symbols that are appearing immediately to the right of a. So while calculating the follow function, initially we have to search where is the particular non-terminal symbol on right hand side. Then for that non-terminal symbol, is there any terminal symbol can be followed immediately to the right of particular non-terminal symbol? Those symbols can be considered as a follow function. Now there is a three rules are there. Now we will discuss one by one. For the starting symbol yes, place the dollar in the follow of yes. So for every contextual grammar there is a starting symbol. For that starting symbol, initially we must place the dollar in follow of yes because of it indication that it is a starting symbol. And the second one is if there is a rule a derives alpha b beta. If there is a rule a derives alpha b beta, then that means where we are going to calculate the follow of b, then where beta must be a non-terminal symbol. If beta become a non-terminal, then follow of b equals to first of beta without epsilon, where the beta must be a non-terminal. Then immediately if non-terminal symbol followed to the b, then we will consider that follow of b equals to first of beta without epsilon can be added in follow of b. That means first of beta without epsilon can be added in follow of b. That is the second rule. Now come to the third rule. If there is a rule a derives alpha b or a derives alpha b beta, where beta can be considered as a epsilon. If there is a beta is epsilon, then what is the follow of b? Follow of b equals to follow of a because of where the beta is a epsilon. In the second rule, beta is non-terminal. Okay, then fall of B equals to fall of A. That means everything in fall of A equals to fall of B. These are the three rules can be applied while calculating the follow function. Let us see the simple example to understand clearly. So that is called as how to calculate the follow function. This is the given grammar. As we know that, so we have to calculate the follow function for E, E dash, T, T dash, F. So for those 5 non-terminal symbols, we are going to calculate the follow function. So as we know that there is a 3 rules are there. For the starting symbol, we must add the dollar. If there is any rule in the form of A derives alpha, B, beta, then beta is non-terminal, then fall of B equals to first of beta without epsilon, that is second rule. And third rule is that is A derives alpha B or alpha B beta, where beta equals to epsilon, then fall of B equals to fall of A. That means everything in fall of A can be added in fall of B. That is the third rule. Now we are going to apply those 3 rules in this context free grammar. So now while calculating the follow function here, now take this one, that is called as fall of E. So we are going to calculate that where is the capital E on right hand side. In this grammar, now we have to verify that where is a capital E on right hand side. Now there is a capital E. F derives, that is called as E. This is the given context free grammar. There is a E. So here, what is the, that is called as the non-terminal symbol here, E. So that means where we are going to calculate the follow function for E. So is there any terminal symbol followed immediately right hand side for the E? Yes, there is a non-terminal symbol immediately followed here, that is called as close bracket. Now we have to add the close bracket here. So our next one is E is the starting symbol. E is the starting symbol in the given context free grammar. That's why as per the rule of follow function, first rule, if it is a starting symbol, we must add the dollar in the follow of particular starting symbol. That's why we are going to add the dollar here. That means fall of E equals to close bracket and dollar, and E is over. And next one is come to the, that is called as E dash. So while calculating the follow function for E dash, we have to search where is E dash on right hand side in the given context free grammar. Where is the E dash here? Now there is a E dash and there is a E dash. Take these two productions, that is called as E derives T E dash, and one more production is E dash derives plus T E dash. That means where we are going to calculate the follow function for E dash. That means now we are going to apply that. What is the rule, required rule? It is in the form of A derives alpha B. Alpha B means we are going to calculate the follow function for E dash. So then that can be considered as a capital B. Now apply the third rule. Fall of B equals to fall of A. Fall of E dash equals to fall of E. What are the symbols in the fall of E? Close bracket and dollar. Those symbols can be considered in the fall of E dash also. The same. Now come to here. This become a capital B. This is the alpha. This is A. Now that means where we are going to calculate that fall of B. So that is called as fall of E dash equals to fall of E dash. What are the symbols in the fall of E dash? Close bracket and dollar. So this is called as how to calculate the follow function for E dash. Now come to the, what is the next one? T. That is we are going to calculate the follow function for T. What we have to do initially while calculating the follow function? Now we have to search where is the capital T on right hand side in the given set of productions. That means now there is a capital T. Now there is a capital T. These two productions, that is called as there is a T and there is a T. Now just wait. Now we are going to take that one more productions here. So that means it is easy to understand how to calculate the, that is called as follow function. Okay. So that is there is a two productions are there. E derives T E dash, and one more production is E dash derives plus T E dash plus T E dash. These are the two productions we have to calculate the follow function of T. That means this become a capital B, this is alpha, this is beta, okay. Now A. Is it right? So, that is called as A derives alpha b beta. Now, we are going to apply that the second rule of follow function. That means, what is the follow of b? First of beta without epsilon. That means, what is the first of beta here? E dash. First of E dash without epsilon can be added in the follow of t. So, now, what are the symbols we have in the first of E dash? Means plus and epsilon. So, plus and epsilon. So, now, we are going to take the only plus. Now, we cannot consider the epsilon, okay. So, because of it is a null value, we cannot consider in the follow function as a epsilon. So, now follow of, that is called as first of E dash equals to plus and epsilon. That means, only we will consider that the plus and we cannot consider the epsilon, okay. And next one is, now come to the second production, that is the first production, okay. And come to the second production. Now, there is a epsilon production, E dash derives epsilon. So, now substitute epsilon in place of E dash, then this production become E dash derives plus t. Because of where we are going to calculate only follow of t. Now, for this t we are going to calculate the follow function. That is why the rule become alpha b, A derives alpha b. That means, so now we have to apply that. What is the third rule? According to third rule of follow function, follow of t equals to follow of E dash. Follow of E dash. What are the follow of E dash here? So, already we have plus and follow of E dash can be added here, that is called as close bracket and dollar. This is how we can calculate the follow of t. Is it right? Follow of t equals to follow of E dash. So, what are the symbols are there in the follow of E dash? Those two symbols can be considered in the follow of t. So, this is how to calculate the follow of t, that is t is over. And next one is, now come to here, what is a follow of t dash? Now, what is a follow of t dash? That means, we are going to do that. What is the first step? While calculating the follow function, initially we have to search where is the particular non-terminal symbol on right hand side, that is where we are going to calculate that follow of t dash. Where is the t dash here? Now, we have two productions with the t dash, that is called as t derives f t dash, and one more production is t dash derives star f t dash. These are the two productions we have, that is where we are going to calculate the t dash here. So, follow of t dash means this become a capital B, this is the alpha, this is A derives alpha b, means now which rule can be applied here? Means that is where we have to apply the only the third rule of follow function. What is the third rule of follow function? Follow of b equals to follow of A, means follow of t dash equals to follow of t. Already we calculated what is the follow of t here. So, what is the follow of t? Plus close bracket and dollar. These three symbols can be added in the follow of t dash, that is plus close bracket and dollar. These are the how we can calculate the follow of t dash. And next one is come to the follow of f. So, t dash is over, t is over, e dash is over, e is over. The final one is f. That means we are going to calculate the follow function for f. So, what is the first step here? We have to search where is the capital F on right hand side. Where is the capital F on right hand side? Now, we have two productions, t derives f t dash and t dash derives star f t dash. There is a capital F, there is a capital F, right. So, now take these two productions, this is E. Now, we will take one more time, that is called as it is clear to understand by taking the productions. T derives that is t derives f t dash and t dash derives star f t dash. These are the two productions we have to compute the follow function for f. Now, there is a f and there is a f. Now, this become a capital B in the particular rule, and this is the alpha and this is the beta and this is A derives alpha b beta. That means we are going to apply the second rule. Okay. So, what is the second rule? fall of b equals to first of beta without epsilon. So, first of t dash, what is the first of t dash? Star and epsilon. So, that is first of t dash equals to star and epsilon. Now, we cannot consider the epsilon here, we will consider only star. So, that is why we will consider the star here. Is it right? So, fall of f equals to star from this production. And next one is, now there is a one production t dash derives epsilon. So, if you substitute the epsilon in place of t dash, then the production become, that is called as t dash derives star f. Because of where we are going to calculate the follow function for f only. If the production become a like this, now that is called as capital F become a capital B, and this is alpha and this is A. A derives alpha B, means t dash become a epsilon. Then what is the third rule? Fall of B equals to fall of A. Here what is the fall of F? Fall of t dash. What are the fall of t dash symbols here? Plus, close bracket and dollar. These three symbols can be added in this one, that is called as fall of F. Fall of F equals to, that is called as a star, that can be taken from this production, and plus close bracket dollar can be taken from this one. Because of fall of F equals to, that is follow of F equals to follow of follow of t dash. As per the third rule, follow of F equals to follow of t dash. This is how we can calculate the first and follow function for the given context grammar. So, remember that before calculating the first and follow function, we have to check that is there any left recursion or the left factoring. If there is any left recursion or the left factoring, initially we must eliminate the left recursion as well as left factoring, then only we are going to move to calculate the first and follow function. Now, come to the second one. What is the final one? That is what is the first and follow for the given context free grammar. So, that is called as totally there are 5 non-terminal symbols are there, that is called as E and E dash and T and T dash and F. So, what is the first function for E? That is called as open bracket and ID and E dash plus and epsilon T ID comma open bracket and T dash, that is called as a star comma epsilon and F, that is called as ID comma open bracket. I already know that first of E equals to first of T, first of T equals to first of F. First of F means ID comma open bracket. These symbols can be considered as a, that is called as first of T. First of T equals to first of F. So, as per the second rule of first function. The similarly come to the follow function. As you know that what is the follow function? Fall of A is a set of terminal symbols that are appearing immediately to the right of A. That means where there is a 3 rules are there. For the starting symbol, we must add the dollar. Is there any production in the form of A derives alpha, B, beta? Then fall of B equals to first of beta without epsilon can be added in the fall of B. That is second rule. And third rule is there any rule in the form of A derives alpha B or A derives alpha B beta, where beta become a epsilon, then fall of B equals to fall of A. Now, we are going to apply these 3 rules onto the given context free grammar. Now, fall of E equals to, that is called as a dollar and close bracket, because of on right hand side there is a capital E for the F production. Now, E immediately follow the close bracket, and dollar is for every starting symbol we must have the dollar as per the first rule of follow function. And next one is that is called as dollar comma close bracket for E dash. So, where is the E dash on right hand side? Initially we have to search where is the particular E dash, and then we are going to calculate that what is the particular follow function of E dash, and that is called as fall of T equals to dollar close bracket and plus, and fall of T dash equals to, that is called as a dollar close bracket and plus, and fall of F equals to dollar close bracket plus and star. This is what is the overview of the first and follow functions. After that, now we are going to discuss about what is the second step of the recursive descent parser. That is recursive, not a recursive descent parser. The second step of the predictive LL parser is that is called as construct the parsing table. Construct the parsing table. Now come to here, the second step of the predictive LL parser is construct the parsing table by using first and follow functions. Before constructing the predictive parsing table, we must know that how to calculate the first and follow functions. So already you know that how to calculate the first and follow functions. Now come to here, the second step of the predictive LL parser is construct the parsing table. Now there is a 4-step algorithm. So what is the first step here? For each a in first of alpha, for each a in first of alpha means a is a terminal symbol in the first of alpha. That means if there is a production a derives alpha, then we have to calculate the first function for alpha. If the first of alpha has any terminal symbol that is called as a, then create entry table m of a comma a. M of a comma a means this a is that is called as left hand side of the production, and this a is terminal symbol for that is called as first of alpha. Then create entry table m of a comma a can be filled with a derives alpha. This production can be filled in the table where a is a terminal symbol. A must be a terminal symbol. That is the first rule. Now we are going to explain that with a simple example. Okay. So what is the first rule here? So this is called as what is a given production here. So now according to first rule, that is called as, so what is the first rule? Now first of for this production E derives T E dash. For this production, now we are going to calculate that what is first of T E dash. What is the first of T E dash? Already we know that first of T equals to, that is called as open bracket and ID. First of T means open bracket and ID. That means we are going to generate an entry table m of a. A means e comma open bracket can be filled with that is called as e derives T E dash and m of e comma ID can be filled with e derives T E dash. So that means in this place where we are going to fill these two productions for the open bracket and ID. This is called as what is the first rule. Okay. So before calculating the, that is called as construct the parsing table, we must know that what is the structure of that is called as a parsing table. On the top of the symbol, top of the table, we have to take that what are the input symbols. On the left hand side, that is called as we will take that what are the non-terminal symbols. For every contextual grammar, there is some input symbols which is called as the terminal symbols and non-terminal symbols, and those non-terminal symbol can be taken on left hand side and the terminal symbol can be taken as a, that is called as the top of the table. Now already we discussed in this one for the, that is called as e derives T E dash. So just now we discussed about that how to fill the particular parsing table for this production. E derives T E dash. First of T E dash means first of T. First of T means that is called as open bracket and ID. So for this one we have to create the entry table m of e comma, that is called as open bracket can be filled with e derives T E dash. That means e comma open bracket can be filled with T E derives T E dash, and m of e comma ID can be filled with e derives T E dash. That means e comma ID can be filled with T E dash. So that is what is the first rule. And come to the second rule here. What is the second rule here? For epsilon in first of alpha and create entry table m of a comma b. That means while calculating the first of alpha, for this one, if we calculate the first of alpha, while calculating the first of alpha here, if there is any epsilon, then those epsilon cannot be considered in the table because of there is no any epsilon in the parsing table. So that's why we will consider that b. So how to take the particular b here? So that is called as where b is a fall of a. That means if there is any epsilon in the fall of first of alpha, then we are going to take that fall of A become a first of, that is called as alpha. Is it right? So, that means now we will take a simple example to understand clearly here. So, that is what is the epsilon productions. Now, there is epsilon production, that is called as E dash derives epsilon. That means first of epsilon equals to epsilon only. That means now in this type of situation, now epsilon means first of epsilon equals to epsilon. What is the second rule says that if A is epsilon, then we have to create entry table M of E dash comma B equals to, what is the M of E dash comma B, where that is called as we have to substitute E dash derives epsilon, where B must be A, that is called as B taken as follow of E dash. What are the follow of E dash here? That is close bracket and dollar. That means where M of E dash comma close bracket can be filled with E dash derives epsilon, and M of E dash comma dollar can be filled with E dash derives epsilon. That means this B symbols can be taken as follow of E dash. So, this is how we will consider that is called as for the epsilon productions. So, for epsilon in follow first of alpha, create entry table M of A comma B equals to A derives alpha can be filled in the table where B is follow of A. That is the second rule. What is the third rule here? If epsilon is in first of alpha, already we know that is called a second rule, and dollar is in follow of A. While taking the follow of A is in dollar, then you have to create the entry table M of A comma dollar can be filled with A derives alpha. This is the third rule. If epsilon is in the first of alpha and there is a dollar in follow of A, then directly you can take the B symbol as a dollar, that is called as M of A comma dollar equals to, that is called as A derives alpha. And what is the fourth rule here? Remaining all entries in the table marked as a error. That means let us see that is called a simple example to understand clearly. So, what is the particular predictive LL parser here? For the first production, already you know that is called as E comma ID can be filled with E derives T E dash and open bracket E derives T E dash. For the second production, that is called as, what is the second production here? That is E dash derives plus T E dash. So, if you calculate that, what is the first of this one? That is first of plus T E dash equals to plus. That means we are going to create the entry table M of E dash comma plus can be filled with E dash derives plus T E dash comma plus can be filled with E dash derives plus T E dash. And there is one more production. So, for the E dash, what is one more production? That is E dash derives epsilon. Now, we are going to apply that is called as second rule. What is the second rule? If epsilon is in first of alpha, then create the entry table A comma B equals to A derives alpha, where B must be taken follow of E dash. So, follow of A, that means there is a epsilon. Now, we are going to take that, what is a follow of E dash. So, follow of E dash equals to close bracket and dollar. Now, how to create the entry table here? That is called as M of E dash comma close bracket can be filled with E dash derives epsilon. E dash comma close bracket can be filled with E dash derives epsilon. And similarly, M of E dash comma dollar can be filled with E dash derives epsilon. That is called as E dash and dollar there is E dash derives epsilon. This is the second production and third production. Now, come to the fourth production. What is the fourth production here? That is called as T derives F T dash. I already know that. So, first of f equals to open bracket and id. That means now we are going to create the entry table t comma open bracket can be filled with t dash derives f t dash. So, m of t comma open bracket t comma open bracket can be filled with t derives f t dash, and there is one more symbol m of t comma id can be filled with t derives f t dash. So, t and id can be filled with t derives f t dash. This is the fourth production, and there is a fifth production, that is called as t dash derives star f t dash. So, for this one, first of alpha means this entire production can be considered as a first of alpha. Then first of alpha means now we will get that what is a star. First of star f t dash means star. Now create the entry table m of a comma star, that is not a here, t comma star can be filled with t dash derives star f t dash. That means t and star, t dash comma star can be filled with, that is called as a t dash derives star f t dash, and there is one production for the t dash, that is called as t dash derives epsilon. So, now already know that the second rule. What is second rule? If there is a epsilon in first of alpha, then take the follow of t dash. So, there is a epsilon here. Now, we will consider that what is the follow of t dash. What are the follow of t dash? So, what are the follow of t dash here? That is called as plus and close bracket and dollar. These are the follow of t dash. That means we are going to create the entry table m of, that is called as a t dash comma plus can be filled with t dash derives epsilon, and m of t dash comma, that is called as a close bracket can be filled with t dash derives epsilon, and m of t dash comma dollar can be filled with t dash derives epsilon, that is plus close bracket and dollar. T dash comma plus can be filled with the t dash derives epsilon, t dash comma close bracket can be filled with t dash derives epsilon, and m of t comma dollar, t dash comma dollar can be filled with, that is called as a t dash derives epsilon. And there is a last production, that is called as f derives e. Now, we are going to calculate that first function, that is we will get that first of e means open bracket, that is we are going to create the entry table f comma open bracket can be filled with f derives e. That is there is a f and there is a open bracket, it can be filled with f derives e. And next one is, so there is one more production for f, that is called as f derives id. You know that. So, that is called as first of id become id. First of id become a id. That means now we are going to create the entry table m of id comma m of f comma id, m of f comma id can be filled with, that is called as f derives id. So, that is now there is a f and id can be filled with f derives id. So, this is how we can construct the predictive parsing table for the given context-free grammar by using first and follow. The last step is, now come to the final step of predictive LL parser, that is parse the input string. So, before parse the input string, we must know that what are the things to be considered in the to parse the input string. Now, there is a stack and there is an input string and there is a action. Stack means the stack can be used to insert the elements to match the given input string. Okay. So, input string can be taken from the given context-free grammar. Okay. And then action means what is the action can be taken, okay, in the, that is called as a stack, that is it a pop or other push. So, basically you know that the stack can perform the two operations, one is pop and push. So, push can be used to insert the elements into the stack, and pop means whenever the top of the symbol onto the stack is matched with the, that is called as input string, then we have to perform the pop operation. So, now let us see here. So, initially a stack contains, that is called as dollar followed by starting symbol. What is a dollar followed by starting symbol in the given production? Starting symbol is E. So, that is why we have to take that E here. Now come to here. So, that is called as what is a given context free grammar. So, here this is the given context free grammar. For this one, now let us take the simple example how to generate the input string here. So, what is a given context free grammar? E derives E plus T or T, and T derives T star F or F, F derives E or ID. This is the given context free grammar. From this one, we are going to generate some input string to parse the input string here. So, now always, as we know that it is LL1 parser. LL1 means scan the input string from left to right. The second L means where we have to use that leftmost derivation. That means already you know that how to perform the leftmost derivation. All the values can be substituted from left to right. So, now what is the starting symbol here? Starting production, E derives E plus T. This is the starting production. For this one, we are going to perform the leftmost derivation by substituting the required values here. So, that is E. In place of E, can we substitute the T here? Yes, because of there is a production, E derives T. So, in place of E, I am going to substitute the capital T, plus in place of T, can we substitute the T star F? Yes, definitely. Okay, that is called as in place of T, where we have to substitute the T derives T star F. And next one is in place of T, can we substitute the F? Because of there is a production, T derives F, that is F plus in place of T, we have to substitute the F, and star in place of F, can we substitute the ID? Definitely, that is ID. And next one is ID, that is in place of F, we have to substitute the ID plus ID star ID. This is how we will get that what is the input string to parse the input string. So, like this where we have to generate the input string and parse the input string here. And next one is, so let us see here. So, now this is called as a stack. So, that is called as stack and input string and action. So, I will tell you that a simple example to understand clearly here. Okay. So, after that we will look at the table here. Okay. So, already you know that what is the input string. Input string means ID plus ID star ID followed by dollar. Okay. Already you know that dollar indication that the declaration is success. That means there is no any input symbol after dollar. Now, in the stack, so initially there is a dollar and we have to take that is called as E as a starting symbol. That means this is the how we can insert the elements here, dollar followed by E. This is called as how the stack can perform the two operations, push and pop operations. Now, E comma ID. Now, we have to verify that is called as E comma ID in the table. E comma ID in the table. E comma ID. E comma ID means now we are going to take that E derives T E dash in the table. That means where there is a that is called as a production E derives T E dash in the E comma ID. That means where we have to insert the values. How to insert the values here? So, initially we have to insert the E dash, after that T. Okay, just like where we have to insert, that is in place of E, that is called as the E dash and T. So, just like where we have to insert the elements onto the stack. That means dollar in place of E, we have to substitute, that is called as E dash and T, and the grammar is ID plus ID star ID followed by dollar. And next one is T comma ID. T comma ID. What is the T comma ID? So, now look at the that is called as a table. So, T comma ID become that is called as ft dash. Okay, so that is called as t dash comma t comma id, that is ft dash. That means where we have to substitute that what is, so that is called as ft dash here. So ft dash means now we have to insert the elements, that is called as dollar. Already there is a e dash and t dash and f. Now compare with the, that is called as f comma id. What is the f comma id in the table? What is the f comma id in the table? F comma id, that is called as there is f determines id. That means where we have to substitute the values, that is called as id. ft dash means id. Now we have to substitute the id. So that is on the top of the stack contains id and in the input buffer contains id. These two are the match. That means whenever the stack and input string can be mapped, then automatically we have to, that is called as pop the symbol from the, that is called as stack. That means after pop the id, now the grammar has, that is called as the productions has t dash and e dash and dollar, and the remaining context free grammar in the input string is plus id star id followed by dollar. What is the top of the symbol here? T dash comma plus. T dash comma plus means there is a epsilon. T dash comma plus has epsilon. That means we have to substitute the epsilon here. Then if we substitute the epsilon, the grammar has e dash comma e dash and dollar. Top of the symbol contains, that is top of the stack contains e dash and top of the symbol here plus. E dash comma plus means plus t dash. Now we have to insert the values. Okay, so that is called as plus t e dash, that is called as e dash t and plus. Top of the symbol in the input buffer is plus and top of the symbol onto the stack is plus. So both are matched, then automatically we can perform the, that is called as pop operation. The remaining grammar is t e dash and dollar. Here id star id followed by dollar. T comma id. What is the t comma id? That is called as t comma id is ft dash. Now substitute the value e dash t dash f and id star id followed by dollar. F comma id. F comma id means there is a production, f derives id. Substitute the id t dash and e dash and id star id followed by dollar. This id and this id are the matching. Then we have to perform the pop operation. Now we have to pop the operation here. Now the remaining grammar is t dash e dash followed by dollar and star id followed by dollar. So now t dash comma star. What is the t dash comma star? Star ft dash. So star ft dash. Already there is a e dash and t dash and f and star. There is a star and there is a star. That means we have to perform the pop operation. And next one is f, remaining grammar is f t dash and e dash followed by dollar. And here there is id dollar. F comma id. That means there is a f derives id. Now substitute the id in place of f, that is called as id t dash and e dash, id on the top of the symbol onto the stack id, and here there is id. Both are matching. That means we have to perform the pop operation. And next one is the remaining grammar is t dash e dash followed by dollar. Here there is a dollar. T dash comma dollar is epsilon and e dash comma dollar is epsilon. That is the finally a stack containing dollar and input string containing dollar. Then you know that it is accepted. That means the given context free grammar is LL1 parser. This is what is that is called as how to measure, how to calculate the given grammar is predictive parser or not. So by considering the three steps, the first one is compute the first and follow. The second one is construct the parsing table by using first and follow, and third one is that is called as parse the input string. Students, hope you understand what is the predictive LL1 parser. That is how to compute first and follow. That is the first step. The second step is how to construct the parsing table by using first and follow functions, and third one is how to parse the input string. This is how to decide that the given context free grammar is predictive LL1 parser or not. Thank you.